Okay, so like we said, if f of x is x squared, f dash x, the derivative of that is what? 2x. And the way you write the integral of 2x, and what you do is you put a dx after it. Okay? The integral of that is, what was our rule? Increase the power by 1 and divide by the new power. So this would be 2x to the power of 2 over 2. Okay? And we add on, the 2 and the 2 cancel, we add on a constant of integration plus c. Because we can't tell, when we differentiate a constant, it disappears. So we can't tell if there was a constant here. Okay? X to the power 7 plus 4x plus 3. If I'm going to differentiate that, what do I get? 7x to the power 6 plus 4. And that 3 disappears. Okay? So that's the derivative. Now let's integrate that to get back here. Okay? So we're going to integrate 7x to the power 6 plus 4. And you just put a dx after it. You can put that in brackets if you want. So, let's integrate that. We're going to increase our power by 1 and divide by the new power. Same here, increase the power by 1 and divide by the new power, so that's just 1 and over 1. Okay? And we're going to add on our c. So we get x to the power 7 plus 4x plus c. Now, they would need to tell us a point. Okay? Like the point, the function passes through the point 2, 0. This would be the function, and if it passes through the point 2, 0, I can fill in my 2 and my 0. Okay, but I'll do an example of that in a minute. So this is this here integrated. Okay, this is the integral. Yeah?
It's not on 4x to the power 2, like if there's add on a power.
Because I'm adding the power to the 4. So that's x. It was x to the power 0, it becomes x to the power 1. Yeah. Okay. Okay, let me throw a few examples down. So, can I get rid of this? Sorry, I'll please. Oh no. No. Can I get rid of the board? Okay, find the integral of this.
Does that sound like an F just without the middle term?
I'll show it to you in here. Okay, so that's what you're looking at, okay? Okay, integrate that for me. Three x cubed over 3. Lovely. Increase the power by 1 and divide by the new power. Same thing here. 4x squared over 2. 5x plus c. Lovely. And then things should cancel. So you get x cubed plus 2x squared plus 5x plus c. Now, in integration, we don't have product rules, quotient rules. Do you remember that? Chain rules. We don't have that. So, for integration, you need to multiply everything out. Okay? You need to just have an expression like this. You can't have one over the other. Okay? Or two things being multiplied, or like this to be squared. Okay? So what you're going to do is you're going to multiply it all out and then integrate it. So that's going to be the integral of, can you remember how to square out brackets? Square the first. Product of the two multiplied by 2. So that's minus 2x by 2 minus 4x. And square the last, plus 1. So this now becomes my sum. I'm now going to integrate that. Everyone okay with this? Yeah, no issues there. So to integrate that, what do I get? 4x cubed over 3, great, minus 4x squared over 2, good, plus 1, x plus c, good. So 4 over 3, x squared minus, x cubed minus 2x squared plus x plus c. Okay. Let's do a few more where we have rules thrown in. So, part 3. Can I get rid of this? Okay, x cubed minus 4x over x. So we need to integrate that. What can I do? Absolutely. Okay, so you can either multiply the top. Well, first of all, what goes into each of them? X. So let's just factorize out the x out of the top, is probably the easiest thing, and then it can cancel. So that x will cancel with that x, and that will become a square. Okay? Or you could factorize it out and then cancel it. Okay? So whichever you want. My sum becomes x squared minus 4. And to integrate x squared minus 4, it becomes x cubed over 3 minus 4x plus c. Good. So that was nice and easy. The x is cancelled. But what if you have something like this? X cubed plus 1 over x squared plus root x. These are only expressions, okay? So they don't have an equals. So I can't multiply unless I'm multiplying to the top and the bottom, because that doesn't change. So you want it to look like this with everything on the top line, okay? And you don't want to have to use any rules like quotient rule, product rule, but we can use other rules, okay? So generally we'd be using our indices rules for these. So x cubed is just going to stay as x cubed, that's fine. 1 over x squared. The power changes to a minus, yeah. So 1 over x squared becomes x to the power of minus 2. Now if it was 2 over x squared, it would be 2x to the minus 2. It's just the power of the x that changes its sign. And what about root x? X to the power of a half, lovely. So now that's much easier to deal with. Okay, so to integrate that, x cubed becomes x to the power of 4 over 4. X to the power minus 2. Increase that by 1. X to the power minus 1 over minus 1. Okay. Here, x to the power of a half. Increase the power by 1. What do you get? 3 over 2. X to the power of 3 over 2. Now you can leave it here like this. Okay, and we're going to tidy it then in a minute. Plus my c. So to tidy this, I'm just left with x to the power of 4 over 4. Now, a minus on the bottom, we always pull it out and put it in front of the top or in front of the whole fraction. So that's minus. X to the power minus 1 is what? 1 over x. Good. Divided by 3 over 2 is the same as multiply by, turn that upside down. Yeah, you're dividing by 3 over 2, so that's the same as multiplying by 2 over 3. You turn your fraction upside down and multiply. Okay, so divided by 3 and multiplied by 2. So I get 2 over 3 x to the power of 3 over 2, and you can leave that plus c. Okay, and one more in this example. Okay, root x by x plus 4. So again, I'm going to have to change the sum. That's x to the power of a half, isn't it? By x plus 4. So still haven't integrated it yet. X to the power of a half by x. I'm multiplying and the bases are the same. What do I do with my powers? Add them. Good. Okay, so that's x to the power of a half by x to the power of 1. So I'm going to add my powers. That'll be x to the power of 1.5, 3 over 2. And then I'm multiplying 4 by x to the power of a half, which is just 4x to the power of a half. Now, I have to integrate that. So x to the power of 3 over 2, increase the power by 1. X to the power of your 5 over 2, yeah. Divided by 5, multiplied by 2. Okay, you can do that in the next step if you want. You're dividing it by 5 over 2. Here, x to the power of a half becomes x to the power of 3 over 2. Divided by 3, multiplied by 2. Plus c. Can't tidy up anything there really. This becomes 8 over 3 plus c. Any issues there? And we'll just do one where we're going to find the c. So example 2. Can I get rid of the board? So f of x passes through the point 2, 0. If f prime x or f dash x is this, find f of x. So when you're integrating, you're going back up. Okay? We're at the derivative, we're going up to the function. We're reversing the process of differentiation. So we're just given the derivative, so we're going to integrate that. And we know when we integrate that, we get the function, we get f of x after you integrate. Okay? But we know our integral will have a plus c. So the function will have a plus c in it. So all we're going to do is use that point to find what c is. So first of all, let's integrate this. To integrate that, I need to change it slightly. Minus 1 over x squared is going to become minus x to the power of minus 2. Great. Okay. Now, let's integrate this. It becomes 3x to the power of 3 over 3 minus x to the power of, increase that by 1, minus 1 over minus 1 plus c. So I get f of x equals, or y equals this thing, x cubed. The minus comes out from underneath and goes in front, so minus by minus is plus. X to the power of minus 1 is 1 over x plus c. That's my function with my constant of integration. Now to find that, you're just going to fill in the point for x and y. Another way of saying y is f of x. So 0 equals 2 cubed is 8, 8 plus a half. So now I found my constant of integration. The question was find f of x, so let's just fill it in. F of x is this thing. And fill in your c.